Hey everyone, welcome back. So, today we're going to be talking about what I've done this week, quick demo. It will be a very quick one this week. I haven't had a huge amount of time and we had a little setback on the project. So, last week we talked about fixing the mapping from plate indexes back to world indexes, and unfortunately that fix did not work. New one does, so that's good. So, I'm going to talk a little bit about why I didn't spot that and just demo the problem and the fixed version, and then I'll throw up the status slide at the end again. Status hasn't really progressed. We are now where I thought we were last week, but I thought it was worth having a reminder. So, current status. The previous attempt at mapping the indices did not work, so I implemented functionality to pause the simulation to make it easier to see what's going on and also to make it easier to record these videos. Doing that, I was able to look at the mapping in more detail, and that showed a fairly major issue. So we'll get to that in a minute, but first here's a cool picture that I was able to take by pausing the simulation. So I really like this, and what it shows is a plate diving down and subducting under a continental plate, so an oceanic plate subducting under the continent. Now, when the simulation is completely finished, there'll be forces that will close this gap up, and so this will actually be under here. But I just thought it was really cool that you can actually see the depth that the plate sinks to, and you get a really good sense of the distance here, which you didn't get before, and this is down to about 500 kilometers. Really cool perspective there on just sort of how big the Earth is and how big some of these processes are. Obviously, in the real world, subduction continues way down to the core mantle boundary, we think. I'm only simulating it to the point where it no longer has an effect on the physics of the simulation. So let's have a look at this is where we were last week, and like I say, we can now pause. So I'll show you that. It starts out paused, and we'll run the simulation for a minute. Now before we do that, this is just a look at the continents versus ocean again. So we're running the simulation, and we'll pause it. And now we can swap between the point mode and the globe mode. So we're seeing the points are plates, and the this version is non-plates. And what you can see is if you look, these boundaries do not match, and this is the major problem you see over here, and they really should match because this here is void, so this should be filled in by these plates, and it isn't, and that is a problem because that will mean well, what will happen is when we try to say, is this a plate boundary, is there nothing above it, it will say no, there isn't, when there is, and vice versa. And that means we won't be generating new crust in the right places where we need to, which is the next thing we're working on. So now now the problem is fixed. So I understand what was causing this, but I'm not going to explain it in detail because it was quite a subtle problem with the old algorithm, and creating diagrams for that is quite tricky. There's quite a lot to it, and it would just bog us down for no good reason. So basically I went back and started again with a completely different approach. This one is based on the one I mentioned before that worked really well but was extremely slow. So basically I've gone back and made that fast. So now it's reliable, and it's also much faster than the previous, not just the first attempt at this approach last week, but also the final approach from last week. This is faster. There's also at least 2 places where I can make it much faster again, but it's not necessary. It's well within budget now, and it's no longer the significant bottleneck. So let's have a quick look at this. So again, we start paused, and we just find a good place, and we will start switching back and forth. We'll run it for a bit, and then we'll start switching back and forth. So here we are. So here you can see immediately these boundaries are much closer, and this is what we wanted. You could also see it ran quite quickly. So one thing to look at here, this does not look lined up and this doesn't look lined up. We'll look at that in a second. So we'll just back and forth a few more times to give you a look at the boundaries on this bit. So then if we rotate this one into the center, now suddenly it is lined up. but this one up here isn't. So if we rotate this one into the centre, this is. And what's going on here is there is a slightly different projection of perspective between these two models, kind of. So this is just an artifact of that projection, but when you look at it straight on, you can see that they are lined up. These line up quite well. Ones on the edge don't. Now, quite how I don't have a good example of that. Quite how bad this effect is varies from plate to plate, because it depends on things like subduction and temperature and age of the crust. Causes a shift in the plate rendering, but not in the globe rendering, and that's what you're seeing. So if it's a big shift, you will very much notice it if the thing we're looking at isn't centered. If it's a small shift, you probably won't, as you saw there. This is not something that will affect the physics at all. The mapping is working properly, as you can see. It's just a visual thing, and you will never actually see that in the game. So that's where we are now. We actually have this working, it's working faster, and it's working reliably, and we can pause the simulation to see where it is. So, status, we are where we were before, where we've created a mesh, split it into plates, we've got the plates moving around, we've got spontaneous subduction happening, and we are now correctly and rapidly remapping plate indices onto globe indices, so that's good. To do, collision forces, induced subduction, I talked about those last week, creating some fresh oceanic crust wherever there's gaps, wherever there is nothing mapped, we should create a new piece of oceanic crust, and then dehydration and hotspots for creating island arcs and chains. And those are all things I'm hoping to work on in the coming week. I don't know how much time I'll have, but at least I can start making forward progress again now that this little issue is fixed. So, thanks for listening. As I said, very quick one this week. As ever, any suggestions, thoughts, comments, very welcome. And I will see you next time.